So in a previous video, I mentioned that there are two ways to create agents in LangGraph. There are two ways to create agents in LangGraph. You can go with primitives. That's if you want to build your agents from scratch. You want to build every single thing about your agents from scratch. And you can also go with LangGraph's pre-built components for creating AI agents. One of the primitive ways for building AI agents in LangGraph is called the Graph API. It's called the Graph API, and that's where LangGraph got its name, as you may have guessed. That's where LangGraph got its name, the Graph API. Now there's the functional API, which is kind of new, as at the time of recording this video. The functional API is kind of new, but the Graph API is what started LangGraph, and it's still what a lot of people use when they are using LangGraph, and it's still the most popular way of using LangGraph. And what it does is that it represents your agent interactions, the decision making, the action taking as a graph. It represents it as a graph. So basically, that's how the Graph API works. And if you look at it closely, as we'll be seeing in this video and a lot of videos to come, it's basically like a state machine. It's basically like a state machine. So you have state being maintained, and across different nodes, state gets to change based on different actions going on. But enough talk. Let us get into the whiteboard and see what the Graph API is all about. Let's see how the Graph API works. So yeah, LangGraph Graph API. Like I said, the Graph API basically represents the agent workflows and interactions as a graph. And it consists of three main parts. So it consists of state, nodes, and edges. State, nodes, and edges. Those are the three main parts of the Graph API. Those are the three main components of the Graph API. Now, let us look at this one by one. Now, your state, and I'm just going to represent that with this. Let's come here. So, let's say this is your state. Your state is the overall data structure that is being maintained across the agent interactions. Is the information that the agent is working with, the information that the agent needs to hold in order to perform its operations. That is what is contained in the state. And the state contains every single variable or state variables representing those pieces of information. Let's say, for example, we use our email example from one of the previous videos. Let me just put it down here. So let's say we want to have an agent that just helps us create and send emails. So for the state, we can say, okay, inside the state, we want it to have sender. We want it to also have recipient. So we want to have sender, recipient. We also want it to have the body of the email. Then we also want it to have a status property. So these are data that are important to the operation of the AI agent. These are pieces of data that are important to the operation of an AI agent that wants to help us build and send an email. Now you can keep adding more based on the needs of your AI agent, but let's say this is what we're working with. So this is the state. And typically you represent your state using a dictionary. You represent your state using a dictionary, even though you can use any data type, but just use a dictionary. It's easy to bundle different types of information inside the dictionary. So that's your state, the operational data that your agent needs to work with in order to perform its task. That's the state. Then we have nodes. So I'm just going to get some circles here. We have nodes. I might be wondering why I'm drawing circles, but don't worry, you will know very soon. Now, what are nodes? Nodes are basically the action takers in your AI agent. Yeah, nodes are the action takers in your AI agent. So any action you want to take, any operation you want to perform, be it calling an LLM, typical code operations, drafting an email, doing a check, validating and stuff, any piece of action you want to perform is performed in a node. So nodes are the action takers inside your AI agent. And typically, nodes are functions. Those are Python functions. Like if we're going by Python, if we're talking in terms of the Python SDK, because there's definitely a JavaScript SDK also. So they are basically functions. They are functions. If it's the JavaScript SDK, they are also JavaScript functions. If it's Python SDK, they are Python functions. So they are just normal, pure Python functions. No need to overthink them. And they are action takers. Now, that's Node, and you can use them to perform any type of action. Any type of action that your agent needs to take. And also think of them as like the steps in your agent's operations. The steps in your agent's operations. Be it fixed steps or conditional steps, they represent the steps in your agent's operation. Now, each node function, let me have some text here so I can describe that. Each node function, let's say def node A, will take as its argument the state of the AI agent. It will take as its argument the state of the AI agent. That's something to note. So every node can take the state of the AI agent and can access it for information that it needs or to perform some of its operations. So that is one thing with nodes. Every single node takes by default the state of the AI agent. They can also take other things that we're going to see later, for example, the runtime context. But looking at AI agents as state, nodes, and edges, every single node in a LangGraph AI agent takes the state. It takes the state, and it can access the state for data and also use that data to perform operations. So that is nodes. That's what nodes typically do. And aside taking the state of the AI agent, they also return the update to the state. They can also return updates to the state. They are basically the components that will be mutating the state of the AI agent. They are the ones that will be changing the state of the AI agent. So, for example, let's say we've finished sending our email and it is successful. In this example, the status variable in the state is going to be changed to success or true, whichever way you want to label the success indicator. You can either call it success as a string or true boolean. So nodes typically return the update or an update to the state when they are done operating. So that's node. Now let us look at edges. What are edges? Now edges typically determine how the flow of the AI agent is going to go. Yeah, they determine how the flow of the AI agent is going to go for the particular operation it's supposed to perform. They are your connectors. So they say, yeah, after you're done with this node, then go to this node. Then once you're done with this node, go to this node. And once this node is done operating, then go to this node. Yeah, those are your edges. That is what edges do. They basically connect nodes. And later on, we will see that this connection can be conditional. It can be conditional because some operations you want to perform are conditional. But just looking at it in a simple form, they connect nodes. So they determine the flow of operations. That's what edges do. They determine the flow of operations. And there's no orphan node. There's a node that is connected to an edge either by a fixed edge or a conditional edge. You can't have an orphan node. Now for fixed edges, you basically just connect them from one node to another. You could typically just connect them from one node to another. That is for fixed edges. But for conditional edges, you can define them as functions. And when you define the edge as a function, it can also take in the state. Your edge can also take in the state of the AI agent. It can also take the state of the AI agent because most likely it needs some sort of state information to be able to take a condition. Yeah, it needs some sort of state information to be able to take a condition. For example, let's say we want to, we have two nodes, one that drafts emails and one that sends emails. It will be good to check if the email has been drafted before we go to the node that sends it, because you don't want to send an email that contains an empty body, that doesn't contain a body. So you can have a condition that checks, okay, is the body property in the state, is it not null? Is it not empty? If it's not empty, then you can direct yourself to the node that sends the email. If not, you go to the node that draft the email. So that is one of the things you can do conditionally with edges. So just to recap, just like nodes, if edges need to perform conditional operations, you can define them as functions, and they're going to determine the next place that you're going to go from a particular node. They're going to determine whether to go to node A or node B based on a condition. So those are edges. And just like nodes also, they can also use LLMs. They can use LLMs. If you want the decision making to be dynamic, yeah, you can always delegate that to an LLM, and the LLM is going to help you to dynamically, or rather use its intelligence to determine the next node to go to. So, but basically, it's pure Python functions, the same type of operations you can perform in your typical Python functions. That's what you can perform in node functions, and also when you need to define your edges as functions. So, to wrap up our whiteboard session, typically, how do you build a graph in LangGraph? How do you build a graph in LangGraph? Now, the first thing you're going to do, let me get out of this green text. Yeah, the first thing you're going to do is to define your state. That's the very first thing you do. You define your state. So you define your state variables, you use a dictionary. There's a StateGraph class. So you use the StateGraph class. The StateGraph class, but don't worry, we're going to see it in the demo. The StateGraph class that you need to define your state. No, I'm not trying to expand that. I'm trying to move it. Yeah, so there's a StateGraph class that we're going to be looking at that you use to define your state. Now, once you have your state defined, the next thing you're going to do is to create your nodes. To create your nodes, that is all the steps that you need in your AI agent. You create them as nodes, and those are basically Python functions that can receive the state of the AI agent. And once you have your nodes created, you connect them with edges. You connect your nodes with edges. Connect your nodes with edges, and once you have all of them connected, you have your graph. But before you run your graph, you need to compile it. Yeah, there's a compile step to your graph. So you need to compile your graph. You need to compile your graph, and once you have your graph compiled, you can then run your graph. Yeah, run your graph. Can I run your graph? So these are the steps that you need to create your graph, and we're going to be doing that in the demo that is coming right up. Now, before we go there, I would like to point out that there are two standard nodes in LangGraph. There are two standard nodes that come out of the box with LangGraph, and these nodes are the start and end nodes. The start node and the end node. Now, LangGraph provides this node for you to be able to define the starting point for your graph and also where your graph is to terminate. Yeah, the starting point for your graph and where your graph is to terminate. That is why these nodes are essential. But we're going to be seeing them in action very soon. So let's jump into Visual Studio Code and build our very first graph. So here in VS Code, let us build our very first LangGraph graph using the Graph API. Definitely. The first step we're going to take is to create a new virtual environment, a new Python virtual environment. So I'm going to do Command Shift P to just use VS Code to create that. So create a new Python environment, create a new Python virtual environment. That's good. Now the demo that we're going to be building, the graph that we're going to be building, is just going to be a simple graph that will take will hold a list of messages in the state. It will hold a list of messages in the state. And we're also going to be using one of LangGraph's built-in functions to update the message list. Don't try to cram a lot of things you're saying in this video. This is just a demo for you to see how graphs work. In the subsequent videos, we're going to be breaking all these things apart, nodes, edges, and having individual videos, even multiple videos that get to treat these topics. So, but for now, enjoy the flow and just try and understand how a graph is built. So once we have this in place, we can then create our file. Create a file. I'm just going to call it graph api.py. Graph api.py. So this is where we're going to be building our graph. Now, before we can build our graph, we need to install LangGraph. We need to install LangGraph in this project. So I'm just going to quickly do pip install LangGraph. And that's how you install LangGraph to your project. Yeah, just the LangGraph package. And it also comes with LangChain as a dependency. So sometimes when we are importing from LangChain packages, it already comes with LangChain, so you don't need to install that separately. So we're going to install this, and that shouldn't take long. But if it takes long, definitely I'm just going to pause the video and we're going to come. So the installation is done. Let us clear our terminal. And for now, just close out of it. We don't need it right now. Oh no, I'm not closing. Yeah, don't need it right now. Now, let us start creating our graph. Now to begin, first I'm going to be importing 3 important components from LangGraph. So I'm going to say from LangGraph, from the graph model, we're going to import 3 things. And that will be StateGraph, which, like I said, is a class that we use to create our state. Then we're going to also be importing the start node, that standard node I told you about. And we're also going to be importing the end node. So those are the 3 components we're going to be importing from the graph module of LangGraph. So say StateGraph, then start and end. So that's good. Now to do some type hinting, I'm going to be importing some, say from typing, import annotated. Also going to import list and also import typed dict. Typed dict. We're going to be using typed dict as our dictionary, for our dictionary to define our state schema. But like I said, there's a whole state video for you to understand all that coming soon. But this is just for us to do some type hinting on the properties that we have in our state. Now, the last thing I'm going to be importing is going to be that special function from LangGraph that I said can help us manage a list of messages. It's basically designed to manage a list of LLM messages. Like I said, more on it later or in later videos. So I'm going to say langgraph.graph.message, and from there we import add message. It's actually called a reducer. It's called a reducer. Add message or add messages? Add messages. Yeah, that's why I didn't turn green. So this is actually called a reducer, and a reducer is basically a function that helps you mutate your state, or rather update your state. So, but like I said, in dedicated videos, you're going to be learning about all this. So yeah, we have the add messages function, or the standard name reducer, and now we can start to create our AI agent. Now, the first thing I said is that there are certain steps we'll take to create our graph. So in order to follow this example easily, I'm going to list out those steps. So like the first thing we're going to do is to define our state. So the first thing we do is define our state. Then we're going to create our node. Then once we create our nodes, we link our nodes with our edges. And after that, we're going to compile our graph. And then we can run our graph. Yeah, those are the 5 steps we're going to be taking to create our graph and run it. So let's start with step 1. So in step 1, we're going to create our state schema, which is going to be a class. We're just going to call it simple state. And simple state is going to inherit typed dict. And inside we have a messages property that we will annotate and say it contains a list of messages, and it is managed using the add messages reducer. So we have our state, and in order to create our graph, I can just say graph equals state graph state graph, and we instantiate it with our simple state. Yeah. So everything starts from our graph. Everything starts from our graph, and what our graph needs is our state schema. So giving it our state schema, so we have a graph now. But our graph is empty. It doesn't have nodes and it doesn't have edges. So let us do that next. So we're going to be creating two nodes. One node is going to add the word hello into the list of messages, while the other node, as you may have guessed it, is going to add the word world to the list of messages. So this is basically our hello world project to LangGraph graphs. So like I said, nodes are basically Python functions. They are pure Python functions, and they receive the state of the graph. So let us create our first node. I'm going to call it say hello. And like I said, it receives the state, which is an instance of simple state. And here we can just print and say executing say hello. Just tell us the node that is in operation. Say hello node. So executing say hello node. And what we want to do here is just update the state. Update the state by adding the word hello into the messages list. And to do that, you simply return a dictionary containing the parts of the state that you want to update. Not all the parts. The parts that you're not going to update, you don't need to return them. Just return the parts that you want to update. So we want to update the messages state variable, and inside it we want to put the word hello. Now, because messages is a list, we always have to represent it as a list. So we're putting the word hello, but we have to put it inside the list. And we can tack on more items to this list. But for now, the word hello is good. So by returning this dictionary, we are telling LangGraph, update this state variable with this value. Now, because we're using the add messages reducer, or the function that is going to be helping us update the state variable, it will append anything we return. It will append it to the list. But later on, we're going to see how reducers work by default, or in the reducers video. But for now, what it will just do is to append whatever we send back to the state into the messages list. So yeah, we have this for say hello. I'm just going to create the second node, and this one will be called say world. So yeah, executing say world, and it will add the word world. To add the word world to our, so in this in place we have our two node functions. Not the node yet, the node functions. We still have to convert them to nodes. So how do we make them nodes? To make them nodes, we come down here, we call on the graph, and on the graph we call the add node function. Now the add node function is going to take two arguments. First is the name that we want to call this node. Yeah, the name we want to call this node within our graph. And I just want to call this the hello node. Then the next function is going to be the next argument is going to be the function that we want to run, the function that this node runs. And that will be the say hello function. So yeah, that's how we add our node. So we can just copy this and add our second node. Our second node, we'll call it the world node. And it will run the say world function. Awesome. So that's cool. We've added our two nodes. Now we have them in place. Now the next step is to link our nodes with edges. So we want to define the flow of the application. So how do we want this graph application to operate? Definitely we want to start. Let me make this a comment. So we want to start, and once the graph starts, we want to say hello first. So we'll go to the hello node. Once the hello node is done, we want to say world. So we move to the world node. And once the world node is done, we want to terminate. want to just terminate our graph. So go to the end node. So that's how we want to operate. So just keep that in mind. Now, the way you add edges in LangGraph is by calling the add edge function of the graph. Call the add edge function, and you can add from one node to another. You can add from one node to another. Later on, we'll see how you can add conditionally to two nodes or decide which one to go between two nodes. But for now, we just go from one node to another. So the first thing we want to do is a graph dot add edge, and we want to go from our start node, that's our entry point node, all the way to our LO node. We'll go to our LO node. Now, here you have to use the names you give your node, not the function names. You can make them the same, and sometimes you can even just pass the function to add node, and it will just assume that the name of the function is also the name of the node. But we're being explicit here, and so that you can see how everything works, so that you can see how everything is constructed. And here you have to use the exact name of your. So here we've defined the first step. Now let's go to the second step. Now here what we want to do is to go from LO node to world node. We want to go from LO node to world node. So just going to put in quotes, say LO node, close out of this. And from LO node, we want to go to world node. From LO node to world node. So that's the next step. First, we went from start to LO node. Then now we're going from LO node to world node. And yeah, definitely for the last step, we'll go from world node to the end node. Yeah, to the standard end node. So let's say add edge. Now let's go from world node and end things there. Yeah, terminate our graph. So we terminate our graph here. So that's good. That's all cool and smooth. Our next step is then to compile our graph. We need to compile our graph. And to do that, all we need to do is say agent. Let's say that's our AI agent variable. Agent equals graph.compile. Graph.compile. This is a very important step. This is how you get your application. This is how you get your agent application. You compile your graph, then you have your agent application. So we compile, and now we're good to go, and we can run this agent application. To run it, first let us define what will be the initial state of the state. Yeah, what will be the initial value of the state? So I was going to say initial states. And for the messages, because that's the only variable we have in state, so we'll just say messages. And for now, messages can just be an empty list. So messages are an empty list to start with. You can initialize with some values in here, but we're just starting clean. So initial state, and now we can get a final state by running our graph, which we have called agent. And what we get back when we compile, this is something to note. When you compile your graph, you get back a runnable. Yeah, you get back a LangChain runnable. So you can call your typical invoke, batch, and stream functions on it. So we get our agent, and we can invoke it with our initial state. You can invoke with our initial state. So we just pass in the initial state. And then we can print out our final state. So I'm just going to come here and say print. Final state. And for now, we'll just print it out raw. So print final state. Print final state. Awesome. So yeah, now we followed all our steps. We first defined our state. We defined the state schema using a typed dictionary. We created our graph by calling StateGraph, passing in our state definition. Then we created our nodes, two nodes, say hello and say world. And we also made sure that we created them as nodes so that the graph can identify them. Then we link our nodes with edges following the flow that we want it to go with. And once we have that, once we have our nodes connected with edges, we compile our graph, giving us back our agent. And now we can give our agent an initial state. I added an extra S. So messages, we create an initial state and we pass it into the invoke function of our returned graph. Because what we get back after compiling is a runnable. So you can do all typical runnable stuff. It has all typical runnable properties. And later on, we're going to see that we can actually configure it like a runnable also. Then we print out our final state. So that's all good. Now it's time for where the rubber meets the road. Let me pull up the command line. Okay. Yeah, I don't need to go down. Pull up the command line. And now let us run Python graph API.py. Python graph API.py. Let's hope that we got everything right. And here we can see the output executing say hello node, executing say world node. And at the end of the day, we get this final state where we have our messages, which is a list, and it contains two human messages. If you look at the content of the first one, it says hello. The content of the second one says world, and those are the messages contained here. Now you might be wondering, why is it looking weird, human message and all that? That's because we used add messages, which is actually built to work with LLMs. So we use add messages to add messages to our messages list. So that's why you're having this LangChain structured message object inside the list. If you use typical strings and we use a custom reducer, definitely you will see that we can just have simple strings inside our list. But because we use add messages, which is built for working with LLMs, we have those message objects, human message objects. So yeah, that's our graph. And before we wrap up this video, I'm going to throw in a bonus, and that is the fact that we can actually visualize our graph. Later on, we'll also see how to use a tool like LangGraph's Studio, which is a more specialized tool for visualizing graphs. But you can also visualize your graphs within your command line. You can even generate like PNGs of it using Marmite. So to do that, let's clear this first. Now, for you to visualize your graph, you need Grandalf. You need Grandalf package. So first, we need to install that by saying pip install Grandalf. Pip install Grandalf, and let's just wait for that to be done, and it's done immediately. So now we can get to work. Let me close this for now. Keep pressing this button. Okay. For this, I'm going to comment out where I'm actually running the graph. So we'll just do that like this. So for us to get a visualization of the graph, we'll say print. We'll take our agent. We'll call the getGraph method. And on the getGraph method, we will tell it to draw the ASCII representation so that it can display well on standard output. Yeah, and that's basically it. Let us see how it looks. Pull up our command line once again. Going to run a file, and boom, we have our graph representation. As you can see, it starts from the start node, then it goes to the hello node. And then from the hello node, it goes to the world node. You can see the nodes are represented as rectangles, and the edges are represented as dotted lines. So it goes to the world node, then goes to the end node. Amazing. And you can use this to visualize no matter how complex your graph is, you can use this to visualize that. And I just think it's just pretty cool.